So this section provides us with an introduction to actually what linear algebra is about when you boil it down to its essence. Linear algebra is about properties of vector spaces. In other words, we want to think now not just about vectors as individual objects that we can kind of push around, but we want to think of them as being parts of a larger whole that has algebraic properties that make vectors capable of doing what they do and render us capable of doing linear algebra with them. Now this section, V1, is one of the most challenging sections in our semester for most students because this is where we take a very quick left turn from the very concrete, let's solve equations, let's get numbers out of it approach that we had in the first chapter, to in this section, we're going to try to think abstractly about what are vectors really. And it's going to be challenging because it's going to ask you to, at times, kind of set aside the things that you know and take for granted about arithmetic and what vectors are and what it even means to add and to multiply. We're going to be trying to expand our minds about that a little bit. And that's challenging. It's also going to require us to think about definitions very carefully. It's going to require us to have the ability to write out a proof that sort of demonstrates that an object of study is or is not a vector space. That's the bad news, right? That's going to be the mountain to get over in this section, and you won't get over it right away. Typically, I think students do end up coming back to revise their work in V1 pretty regularly when I teach this course. But the good news is that once we do this work to understand what is a vector space really, this is the work that allows us to apply linear algebra as broadly as linear algebra gets applied. It's going to allow us to spot examples of vector spaces even in contexts that look like they have nothing to do with points inside of the xy plane, right? Vectors can be a lot of things. Vectors don't have to be points in a Euclidean space. Vectors can be, digital images stored on your computer can be vectors. Sound signals, sound waves that sort of define an audio file, those can be vectors. We can think of vectors as being functions. Certain kinds of functions can be thought of as vectors. And so because there are all of these different things that walk and talk just like vectors do, we can use linear algebra in exactly the same way that we use linear algebra in sort of the ordinary sense that you're used to study those other kinds of vector spaces. And so this step of abstraction, where as mathematicians we kind of take a step back from the particulars and sort of try to see what is the big picture, what is the structure that makes linear algebra work, is challenging to do because it requires that abstract thinking. But it is worth the effort that we put into it because this is what's going to make linear algebra for us something that is so flexible. And so the examples of vector spaces that we study for the rest of the semester, those that are not just points inside of a Euclidean space Rn, we're going to also look at spaces, vector spaces made of polynomial functions and vector spaces made of matrices, which is kind of interesting. There are a bunch of other examples also, but those are the two examples that are going to power most of our investigations in the rest of our semester of this course. So in the next video, we'll get started. I just want to give you a short introduction to what it's going to look like to do that abstract reasoning process to help you prepare for the first activity in section 2.1.